Hello learners, welcome to YourPedia Education. So today we are here at IIT Mandi and I got an opportunity to interact with Professor Shrikanth. So his current research area is RF and microwave design. So in this discussion, we will dive into what kind of research activities going under his research group and what is basically focus of his research lab and what are the various research domain in which he is actively contributing. So before proceeding ahead with the discussion, first of all, welcome
Thank you.
and thanks for sparing few minutes for us.
Thank you.
So Shrikanth, before proceeding ahead, can you please give your brief introduction about your academic and whether this is your first job or not?
So I did my PhD in 2015, and after that I did a small postdoctoral research fellowship, at State University of New York in Oswego campus. I did my postdoctoral there, and then immediately after that I joined IIT Mandi as an assistant professor in 2016.
So this is your first job, right?
Yes, this is kind of first job.
So you are here since 2016.
Yes, November 2016.
So almost 7 years completed.
Almost 6.5, I would say.
Almost 6.5. Right? So how's your experience in IIT Mandi?
So far it has been a good experience here. I met different people, different students, and we have different weathers also here. So it's been a good process throughout. Yes.
So can you brief about your current research area? What are the areas in which you are actively contributing right now?
Okay. So right now I have two research legs which I'm working on. One of them is related to this RF resonators, which we call as frequency selective surface. So these resonators, their applications are to absorb microwave signals. It can also be used for energy harvesting by absorbing, ambient RF energy and converting into a usable energy. So basically, you work on this frequency selective surface based resonator. This is one leg. Another leg is I am interested in developing small antennas which can be integrated within your handheld devices like mobile phone, dongles, these type of antennas. So my second leg is more oriented towards industrial application, where you develop such small antennas using very simple techniques which can be scaled. Say for example, today you are working for say X frequency in your mobile phone, tomorrow you change your frequency. So when you change your frequency, you need not to change your antennas entirely. You can just scale it to that frequency. So we are working on those techniques in which scaling can be done very easily.
So are you working in collaboration with some other organization or as IIT Mandi only?
Yes, we do collaborate because you see, academic institutes have a limitation of labs in terms of academia only, right? So you have to collaborate with industry to get industrial grade labs. Plus, you need to understand industry related problem. So basically, you collaborate with industry. So, but since I work on this RF and microwave domain, the prime industry here is like this defense labs. Then I collaborate with this National Aerospace Lab for this absorber designs. I collaborate with them. Then there are the space industry is there. We do collaborate with some applications there.
So I want to ask you one question. Under the School of Computing and Electrical Engineering, this specific research area comes under which category?
So it comprises of both. Like we have different aspects. So we have computing. Computing means we use some computational technique. Then we have some part of communications here. Then some part of VLSI is also added. So it's an amalgamation of 2-3 technologies together. But the base of all these technologies is electromagnetic theory, or you can say electromagnetic physics.
At least from the beginner point of view, we can say
Yes.
you need to have a keen interest in the
Electromagnetic theory, yes, or engineering physics.
concept of
Yes,
physics as
yes,
well.
yes, exactly. Yes.
Okay, so here on the behalf of the budding researcher who are aspiring to become a researcher. So now we have two kind of PhD program in our Indian education system. One is obviously which is the very regular route you can do
Yes.
after MTech.
Yes.
So now the student are joining PhD directly after bachelor also.
Yes.
So what would be your recommendation for those students that what should be your mindset before joining the PhD?
Okay. So see, I generally give things or take things as with respect to some examples. So I'll give you my example that For me to join PhD, I had a problem in my mind, and then I started understanding that problem and trying to find a solution. Then, in that process, I found a place where I can do my research, found a person whom with I can associate my research with, and then I did finish my PhD. So I would give this advice to all who wish to work for PhD, either you do after master, BTech, or whenever. Please have a problem ready with you, or try to foresee which problem you are going to work with. You see, when you have started your engineering, you had a goal in your mind. You didn't went to engineering blindly, right? You had certain aspiration. So for PhD also, or for doing any type of research also, you should have certain goals. That goals will define your problem, that I'm going to solve this, right? So with that aspiration, if you are coming, I would say the quarter of your work is done. Then when you come here, we will try to feed you with different technology techniques, and then we will work with you to come up with a novel solution.
Right. So ultimately, conclusion is that you are not expecting novelty in the problem at the very beginning stage, right?
Yes, at the beginning stage, no. We are at the beginning stage. We are expecting that you understand the problem, because only then we will see. See, we want to have a novelty, but we want to have a novelty in the solution set, and that novelty should be acceptable by market also. You can say that I have, like, say, a scientist can say that I've discovered gold and I can have discovered copper. They both are conductor, or silver is also conductor. But for market, which conductor is more beneficial? So, for that sense, we need to see what is more usable for industry and market.
Mr. Srikanth, that is you refer electromagnetic field theory. So electromagnetic field theory, I believe, is a kind of subject which also need multidisciplinary knowledge, be it mathematics, be it physics, and all, right? So preparing electromagnetic field theory for exam, just to write the exam, is something different. But when you're preparing this topic from practical aspect of view, so what should be in the mindset of the student, especially?
Okay, so see, when you understand this theory, please don't understand it as per the normal theory, or you just read some definitions. No, try to see what is the practical aspects of that. Okay, so say when someone says that current will come when there is a field, or when magnets move somewhere, something happens. If you hear stuff like that somewhere written in the book, try to see that where are these things practically applicable, because any machine you see, any functionality you see, are derived from these normal aspects only. If those aspects are not there, you would have never seen the advanced science and technology advancement what you see today. So you see, for all these theories, you need to understand that there is an application. We are working on application. For my case also, I design things for certain industrial applications only, though we deal with some theory, because theory is basically the backbone of everything, but we try to see that as a in terms of a practical aspect, where this theory is practically applicable. So we design product for that. Okay, so that is how your perception should be, that every theory has to have a practical
So currently,
application.
are you taking your PG courses, UG courses, or PhD courses?
So it's mixed. So I take UG courses also, I take PG courses also.
Okay, so how many students are currently under your guidance for PhD?
So right now, I've graduated one PhD student and two master's students, and right now two more students are working with me.
Okay, so I want to know one more logic behind the PhD. That is it right that one should think of what will be the placement opportunity, what will be his career once he will complete the PhD? Is it wise to anticipate when you're starting the PhD? What's your take on this?
I mean, you see, placement should not be your criteria when you are entering PhD, or placement should not be criteria whenever you are entering any domain, either BTech, MTech, or anything. You are here, you are entering to a particular domain to find out a solution for certain limitations. Once you have found those solution, then of course the placement will come. Why not? Because you see, you have identified a problem, a well-defined problem, which you foresee that that problem is coming for a very long time, And now you have, after say 3 years of your research or your experimentation, you have found a solution for it. So why industry will not be interested in you?
Okay, so you told me that you are taking some courses of VLSI, also some communication, also basically. But when student hear this name first time, RF and microwave, so for them it seems totally like it's a communication domain. It's not actually because there is designing a lot of software code, right?
Yes, yes.
So if somebody is having passion for this domain, RF and microwave design and RF and microwave component designing, so if he wants to approach you, according to you, what will be your requirement from the student point of view, at least?
Okay. So if a student wish to work in those domains, first I would like to see that if that student has passion for this engineering electromagnetic theory, means that student has a fair understanding of that. Then say if the student has done his master degree, then I would expect that student know what application he wish to work for. Okay, so because if I know the application, it would be easy for me to understand the problems. Okay, so then only I'll work for an application, right? So I would like to see that if a student has a fair understanding of current problems, then we can work with different techniques and find out the solution.
Great, great,
Yeah.
great. So I want to ask you one more suggestion and your view about this, right? Obviously, it can vary from person to person.
Yes.
See, what problem you see in the today's youth or today's student that they are not much passionate about the research.
Okay.
Everybody want to get into industry. They want to get a very shortcut method of earning the money. Very rarely you will find the students who are highly motivated to go into research. So what is the reason behind it? What will be your suggestion to students that how this PhD is going to help them in the long run, being as a good career perspective and in terms of the knowledge also.
Okay. So, see, there is, from my perspective, the problem not entirely lies with the youth. Problem is sometimes about the society also, that what type of perception society has built up
Right,
and what type of expectation they are looking for. So, to satisfy those perceptions, the youth develop their own ideologies to satisfy those perception, and then because of that they work for these things. Now see, the background which I came from, or the research, I have seen people who have left very high earning jobs to pursue research from their base university or the colleges. They came back and did pursued fundamental research. So it's the question the youth should always ask is that say you have satisfied some societal perception. Okay, you got your job, but after that what was your own thought? What was the, yeah, thought of, like, thought or area of interest which you wish to work on? What was that? Or when that will happen, or when you will have time to do that? Okay, once they understand that, they can understand it after doing some job, or they can understand it before taking up some job and then pursuing their interest. They can do that. Yeah.
Okay, so thank you so much.
Thank you.
For your valuable insights and
Sure.
experiences. This will
Thank you.
definitely help a lot of students.
Yes.
Right? Thanks, Shrikanth.
Thank you. Thank you. Yeah.